today we're talking about lab equipment. First thing I want to cover is the Bunsen burner. There's a whole bunch of equipment that is involved in it, so we're going to cover all that stuff over here, and then we'll talk about the why. Why are there even, why? Bruh. Okay, stop ringing at any time. We'll set you on fire. Okay, so Bunsen burner. When you're looking at the Bunsen burner, the nozzle turns the gas on and off. Right? There are a few of those set up around the classroom, and it looks like that, where you've got just little plugs sticking out, and there's a little handle on there and a nozzle. Okay, there are a few different ways that this thing can be set up. If the handle is pointed towards the wall, all right, so you got your nozzle, you got your handle, 90 degrees. Okay, that means that it's off. Okay, no gas is going to come out of there. If you've got it turned all the way around, so if I bring it all the way over, this is also off. Okay, so if the handle is 90 degrees to the nozzle, it will be off. Doesn't matter which direction it's going. Stop. Stop. Man, there's gonna wait. Is that the minute bell then? I don't know. There may be another one. Who knows? So both of those are off. If we want to turn it on, it has to be parallel with the nozzle. All right. So right now, it is on. All right. If you see a nozzle that isn't 90 degrees and we aren't using Bunsen burners that day in class, make sure that you turn it off. Okay. Because we can't breathe the gas that's coming out of there. It's methane. It's highly flammable, and we can't breathe it. All right. So they put a little indicator in the methane so that you could smell it. Some people can. Not everyone can. It smells kind of like rotten eggs. All right. So if you smell that, make sure that you tell somebody. Make sure you try and find the nozzle. Make sure you turn it off. Okay. If I see you screwing around with these and we aren't using them in the lab, you're out. All right. These are not toys. Okay. So now we know how to turn it on. There are a few different ways for us to light these. All right. One way is these little guys. There's a kind of ridged piece of metal in there and a piece of flint on here. So if we do that, it will make a little spark. This one happens to be worn out. There's no more flint left, so it's not going to make a spark. This is no good. All right. We may also use just these little candle lighters. All right. Again, remember, fire is not a toy. So you screwing around with one of these, you're out. All right. My favorite way to start the Bunsen burner is using this right here. This is a high frequency generator. It makes a little arc of electricity when brought near metal or people. Okay. So who needs coffee? This wakes me up plenty fine. All right, so when you are setting up your Bunsen burner, you want to turn on your gas. Okay, so I'm going to turn on the gas over here. All right, now I don't currently hear it hissing out gas. The reason for that is the Bunsen burner itself has a little nozzle on it as well. Okay, so I'm going to put on my goggles. Whenever you're dealing with any sort of lab setting, make sure that you're wearing all your safety equipment. Okay, now I'm going to turn this little twisty knob down at the bottom. That changes how much gas is allowed out of the Bunsen burner. Okay, you can hear it hissing right now. So that means that there's gas flowing in. All right, you try and light it and there isn't any gas coming out, you're just holding a flame over a Bunsen burner that's off. All right, so I got gas coming out of there now, and I'm gonna light it up. All right, now you might not be able to see that on the video because I got a white background and it's kind of far away. All right, but there is a cone of flame coming out of there. I kind of drew a diagram over here. Okay, if this thing is set up properly, that flame is going to be blue. Okay, it'll also have two cones on it, an outer cone and an inner cone. All right, when we're using these Bunsen burners, you're trying to heat something up, you're going to make sure that it's right on top of that inner cone. That is the hottest part of the flame right there. Okay. The other setting on this Bunsen burner allows different amounts of oxygen in it. That will change the nature of the flame as well. Okay. So right now, there's a lot of yellow coming off of that flame. Again, I'm not sure if you're going to be able to see that in the video. Screw it. I'm just going to bring the camera over there. So you can see the yellow part of that flame right there. Okay. The reason that's happening is because there is the wrong amount of oxygen compared to methane. All right. It's an inefficient flame and it's not as hot. Okay. If I turn this, then you can see that it goes all blue. All right. So when we're using these Bunsen burners, you want a blue flame. You may see little sparks of red. That's because there is some salt stuck in here. Not table salt, different type of salt. I think it's strontium chloride. But we were doing a lab in chemistry last year, and there's just a little bit stuck in there. It'll burn out. So when you're doing a lab with a Bunsen burner, make sure that you've got a nice blue flame. Anything other than that is inefficient. Okay. So next time you're out camping, you have a nice, pretty yellow flame going. Here's what I want you to do. Walk up, start kicking dirt in it. Tell everyone that you're camping with, that's an inefficient flame, get it together, and then walk away. It's a great way to lose friends. So when you're done doing a lab with a Bunsen burner, make sure that you turn the nozzle at the bottom to cut the gas, and then turn the nozzle over there at the main valve. Okay, turn it off at both places. Let's talk about some other stuff over here. This is a ring stand. It's used for lifting things above that flame. Okay, there are a few different things we can stick on it. This is a ring, hence the name ring stand. Okay, so this slots out of here, and then there is a little screw to tighten it up. Okay, now you may be noticing if I'm trying to stick something on there, there's an issue. There's a big old hole in there. If I put something on, it's just going to fall through. That's no good. All right, so we're going to need one of these. All right, so this mesh will hold things over the flame and not allow them to fall through the ring. I can place stuff on top of it now. All right, another way that we can do it, depending on the size of what we're putting over the flame, is using these little ceramic triangles. Okay, so if I was using a bigger crucible, that thing would nestle in real nice, but this crucible is a little bit too small that it would fall right through. Okay? So make sure you know the right size to put into those little ceramic things. Most of the time, if we're putting stuff over a flame, we're going to use one of these. Okay? This little cup that I just put over there is called a crucible. It's a little ceramic cup. It's used for heating stuff up. You'll notice there's a little lid for it. That's because if we're heating stuff up over a flame, there's a pretty good chance that it might splash. That's one of the reasons that we wear goggles, not just glasses, goggles. Okay? So make sure that whenever we're using a Bunsen burner, you've got goggles on, you've got an apron or a lab coat on. All right? Another way for us to suspend stuff over the flame, other than that ring, is one of these, a clamp. Put that over there. This one is just the right size for putting the test tube in. All right? Make sure that that thing is nice and tight on the test tube so that it holds when you let go. All right? And then you can adjust the height of these as well to fit your flame. All right? I think that ought to do it for all our equipment over here. Let's go look at the other stuff. All right, so we got a whole bunch of other toys to talk about now. I've got this little list over here, that sheet that you're going to be working on, identifying what things you're used for. I'm just going to be keeping track, making sure that we cover all the ones that are important. All right, so we already did all the Bunsen burner stuff. Let's talk about the stuff on this table. All right, so one thing that I probably should have shown you when we were talking about the Bunsen burner was this little guy, right? Kind of little itty bitty cereal bowl. So this is an evaporating dish. It works a lot like that crucible does. It can get really, really hot, but it's got that nice open brim so that liquid can evaporate off. So if you got something that has a bunch of water in it and you want to get just the dry stuff left over, you put it in an evaporating dish, put it over the Bunsen burner. Okay? So that's our evaporating dish. Some other things we've got over here. This is a mortar and pestle. So there is a little grinding stick right here, and then another ceramic dish. All right, so if you had something like calcium chloride, makes look like little, what are those? It's like a fast frozen ice cream sort of thing. Kind of looks like Orbeez, but it's delicious. Anyway, so calcium chloride kind of looks like that, and if you want to dissolve it into stuff, you really got to grind it down. So you can, ooh, listen to that terrible sound. Gross. So using this, you can just grind stuff up. Makes you feel like a wizard. All right, so this is a mortar and pestle used for grinding things to dust. These are little test tube clamps. All right, so if we wanted to observe our test tube, if say we had put this over a flame and it was hot and we wanted to look at it, okay, this grips onto there. You can hold it without touching it with your fingies. All right, so this is for holding test tubes. This is a test tube. All right, so this is used for holding liquids, making observations, heating sometimes. All right, when you're done with one of these, make sure that you clean it out with one of these brushes. Now this is a comically large one. There are some smaller ones, but I couldn't find them. But we just shove that sucker on down in there and then clean it out. Make sure you're doing that over a sink so you don't get crap everywhere. All right, so this is a little brush for cleaning out glassware. All right, when you're done cleaning it out, or if you're leaving it overnight for a reaction to happen, use one of these little test tube racks. All right, now these do come in different sizes. There are some with significantly larger holes, and depending on the size of your test tube, it may fall out. Okay, so make sure that the test tube fits properly and is held up when you put it into the test tube rack. All right, so there's a test tube. Oh, also speaking of test tubes, let's say that you wanted something to react and not release any gases or anything. We do have little corks. All right, so those can be used as stoppers. This wouldn't be great for gas because there are holes in the top of it, but if we wanted to reduce like the chance of something splashing, this would be a good thing to use. All right, this does have a little wire on there so it can be easily removed from the test tube. Okay. So, test tubes are for holding liquids. Some other things that hold liquids are your beakers. Okay, so these do have a little bit more precision in how much stuff you're holding. They've got that little graduation on there. It's not used for measuring out liquids though. All right, if you want to get a specific amount of liquid, you're not using a beaker to do that. There's not enough lines, enough graduations on it for you to know exactly how much is in there. All right, but you do have a general idea of how much is in it because of the lines on there. It tells you how much it should hold at most. Like this is a 100 milliliter beaker, this is a 250 milliliter beaker. They can hold a little bit more, but beyond that, there's a lot of issue with splashing. Okay, so these are used for holding liquids. You can also put them over heat. All right, but these are not specifically used for measuring out how much you've got. Okay. Also, if you are trying to cover one, you want to use one of these observation glasses. What do they call it on this? Watch glass. Okay. So, like if I wanted to put some isopropyl alcohol in here and I didn't want it to evaporate away, I can put one of these on there. A little bit will still get out of the little pour spout, but significantly less will evaporate away. So this is just used to cover a beaker so that stuff doesn't get out. Okay, so I'm gonna real quick check off the ones that we've looked at. We have looked at the evaporating dish, we looked at a mortar and pestle, we looked at test tubes, we looked at beakers, we looked at watch glasses, we looked at corks. Oh, we're doing great. All right, next we've got some Erlenmeyer flasks. Again, these are not used for measuring amounts of liquid. All right, there are lines on here so you have a general idea of how much is in it, but if you're looking for a specific amount, you don't want to use this. Okay, like if I wanted 410 milliliters, I got a 400 line, I got a 450 line, but it'd be really hard to estimate exactly where 410 would be. Okay, so not used for measuring liquids. The purpose of these is holding stuff and having something that's easy to mix things in. Because of the smaller neck up here, there's gonna be a lot less splashing. So you could put two liquids in there, swirl it around, make sure it gets mixed up. Now for these, there are a whole bunch of different sizes, right? So just like beakers, think about how much you need for the lab that you're doing. This one goes up to 500, this one goes up to 250, and this adorable little boy, oh yeah, little guy, it was like a 50 milliliters, he's so small. This is a cute Erlenmeyer flask. Look at it, it's so adorable. Just want to shatter it. Don't do that. So, we got our Erlenmeyer flasks. Those are they. Up next, let's see. So, burettes and pipettes. There are pictures on here. Now, I don't have any pipettes. I do have some burettes back there, but we're not going to be using one of these. This is for letting a certain amount of liquid drop down into something. You just open it up and it pours out and there's a little graduation on there. You can tell exactly how much you have let in. These are kind of fragile, and we're probably not going to be using them in this class. You may use one in chemistry, right? But probably not going to be using it in integrated science. All right. When we are trying to move liquid, we're probably going to be using one of these little micro pipettes. Okay, so a little eyedropper basically. So there is a little tiny bit of graduation on here, so like 0.5, 1. All right, but it's really hard to use that graduation for this. If you want to move small amounts of liquid from one place to another, just boop. All right, again, not toys, even though they are so much fun. Don't use them as a toy. All right, it's a micro pipette. Moves small amounts of liquid from one place to another. Let's see. So I have mentioned that a few things are not used for measuring volumes of liquid, like beakers and Erlenmeyer flasks. These are graduated cylinders. These are for getting specific amounts of liquid. All right, and depending on how much liquid you've got, they go to different degrees of precision. Like this one goes up to 1 full liter of liquid. All right, and each one of those little lines goes up by 10 milliliters. Okay, so if you want a whole bunch of liquid and you don't need it to be super precise, this is what you're looking at. Okay, but this one also measures your liquid. Okay, so this one goes up to only 100 milliliters, but it has lines for every single 1 milliliter. All right, so this one is more precise than that one, but it doesn't measure as much liquid. All right, I've got a few even smaller ones that go to even more precise numbers. All right, now you may notice that it's got this little ring on here. This is not for measuring how much you've got in there, like putting it at the liquid level. This should be staying up towards the top. The reason that's there is to try to prevent it breaking if it fell. Okay, so if you've got that up at the top, that hits the ground instead of just glass. Okay, so it's less likely to break. I have still seen them break with this thing all the way up. Okay, so be very careful whenever you're dealing with glassware. Make sure that you're holding it solidly. Make sure that it's over a surface, not just held over the ground where you might drop it. All right, be careful with these. And if you do break something, make sure you come talk to me. Do not try and pick it up yourself. All right, so those are our graduated cylinders. Those are for measuring specific amounts. Base which graduated cylinder you use on how much you have to measure. Okay, graduated cylinders. Alrighty then. Next we've got some tongs. If you need to grab some hot glassware or something, using one of these. Make sure that you get a solid grip on it. Okay, so like this, I can feel it holding, all right, but if that beaker was any larger, it might slip out as I'm using that. So the way I suggest using these tongs is make sure you can feel a solid grip on there, all right, and you want to get as much surface area on there as possible. All right, so this is for moving stuff around when it's hot. All right. Forceps, tweezers, is just for grabbing little small stuff. All right, if you've got to move one liquid from one place to another, and it's got a small opening, you're using one of these funnels. We'll have some filters in case we need to get a solid out of a liquid or something. Funnel, everyone knows what a funnel is. Okay, next, we've got some of these digital thermometers. Okay, I couldn't find all the analog ones. I don't know where those are at. So previously they used to make thermometers with mercury in them, but if they break, then you have to deal with all the safety procedures for that. So the current ones that we have do not have mercury. That does not mean that you should be lackadaisical with them, all right? They're still made out of glass. They can still break. They're still dangerous if they're broken, all right? So this one, it's got a little on-off button. You can change it from Celsius to Fahrenheit. We're gonna be measuring stuff in Celsius. It's a science class. We do not need American units, all right? So we got some digital thermometers. Turn off already, there we go, all right. Got some digital thermometers when it's time to measure temperature, all right? Goggles, make sure these are on whenever we're doing a lab, all right? Doesn't matter how safe it seems. We may be doing a lab with water. You're still wearing these, right? It's a good practice, and who knows if there's something else in that water you don't want in your eyeballs, all right? Safety always first, even if it seems ridiculous to be that safe. Okay. Oh, look, over here. I've got one of my other even smaller graduated cylinders. How about that? When you're measuring with a graduated cylinder, because of the shape of this thing, the water is going to appear curved. It literally is curved. The water sticks to the sides. When you're measuring, you want to make sure that it is on a flat surface, and you want to be eye level with it. If you view it from above, something called parallax will appear to be at a different point. So make sure that you are at eye level, and on the curve on that liquid, you want to measure at the bottom of it. This is called the meniscus. Okay? If you measure from the top of that curve, you'll end up having a larger volume than what's actually in there when you're taking your measurement. All right? So it will curve. Make sure you're eye level. Measure from the bottom of that curve. Okay? So, next, we got some wash bottles. All right, so these just have water in it. Some nice distilled water. Okay, so if you need to clean something out, spray it on in there. Do not spray each other. As much fun as it might seem, only spray things that need to be sprayed. Not my floor either. Why am I setting a bad example? Okay, so there's our wash bottle. These called spoonulets. Okay, it's like a spatula, but it can scoop things. It's a weird shaped spoon. We use this to get dry stuff from one container into another. Just scoop out little bits at a time. Okay, and this is a sample bottle. On your sheet, it has a glass bottle on there. We use plastic. So usually you're not going to be dealing with these because this will be my sample bottle that's been mixed with a certain concentration or something. All right. If there's something that you're going to be using, it's probably going to have been poured into a beaker and it'll be out for you guys to use. So you're not going to really have to worry about the bottles that I've got because they're my bottles. Back off. Okay. This is a stir rod. It's made out of glass, so be careful with it. Don't bash it against stuff. But we just use that to mix stuff together. Okay. Be careful with these. They do like to break. All right, and it looks like the last thing we've got is our triple beam balance. So I'm going to move the camera so we can show how to use this thing. Okay, so let's say that I'm trying to get the mass of this Dr. Pepper right here. Okay, you'll notice that when we're looking at the scale, that little beam is now above that line. Okay, you need these two lines to match up. Again, just like a graduated cylinder, you need to make sure that you're looking at it eye level. Okay, so a few things. First off, before you even use it, you want to make sure that this thing is properly calibrated. Okay, there's a little knob over here. If you turn that, it changes the calibration. Basically, this little plug goes in and out, and it will change where the center of mass is. Okay, so with nothing on it, you want this to line up right at the line. Those two lines should be completely level. Okay, now this looks a little bit lower than level, but it's good enough for government work, so we're going to do it. All right, so putting our thing on there. This thing goes up because it's too heavy. All right, so we're going to adjust these little beams. All right, the first beam up on top goes up by 10s. You'll notice that there are little notches in there. If I move this thing over, it falls into those notches. If it's in between the notches, it moves freely, and then it falls into the notches. Okay, so you want to make sure that it is solidly in one of those notches right at the number. Otherwise, you won't know exactly what your measurement is. The same thing happens on your hundreds. Okay, so it gets stuck at the hundreds, but can move freely in between them. So make sure that those little markers are directly in the notches. All right, the ones column moves freely though. Okay, this is because it's got like little tenths of a gram on there, so you can get a more precise number. All right, but the hundreds and tens, make sure they're solidly in their notch. All right, so now using this thing, we've got our hundreds first. Okay, it's still above the line, so that means I don't have enough mass. So I'm gonna move it up a little bit more. Still above the line, that means I don't have enough mass. Still above the line, that means I don't have enough mass. All right, so that went down now. Okay, that means that the scale is too heavy. Okay, so 400 was too heavy. I'm going to move this back to 300. Okay, now I'm going to move the tens. Okay. 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 Oh, this thing's going to wait until the very end, isn't it? All right, there we go. So 390 was too heavy. So I'm going back to 80. All right, so now I'm going to move the ones column until this thing balances out. All right, now some of these scales are a little bit old and they get stuck. Okay, so if you're dealing with one that doesn't seem to be moving properly, make sure you bring me over. It may take some convincing. This one feels pretty fluid. I like it. Just moving things around just a little bit at a time. If it goes below the line, that means it's too heavy. If it goes above the line, that means it's too light. So then you just adjust until it lands perfectly on there. Okay, so that's looking pretty good. All right, so now reading this thing. Okay, I've got 300, 80, and then this goes to the 6 and then halfway to the 7. So this would be 386.5 grams. All right, it's just like these scales that they use at the doctor's office, except for stuff that's a lot smaller. All right, so whenever you have to use those, make sure that you check it's calibrated right. It should be right at the 0 when there's nothing on it. All right, then once you put something on, move the hundreds first, then the tens, then the ones. All right, make sure that the hundreds and the tens spaces are nestled into those little notches. All right, so that ought to do it for all of our equipment. There are a lot of toys for us to use. Should be fun.